For the gospel reading this morning, I've chosen a passage from John's Gospel, and it's one of my favorite scriptural passages of all time. It's from the prologue of John's Gospel, and John was writing in Greek. So there's one word that I prefer to keep in the original Greek because the translation doesn't do justice to it, and it's the word logos. And logos in Greek means a kind of a morphological agent, that which brings form into being, or that which brings life into being. It's a kind of the causal force. So I retained the original Greek word here. In the beginning was the Logos, and the Logos was with God, and the Logos was God. The Logos was with God in the beginning. Through it, all things were made. Without it, nothing was made that has been made. In it was life, and that life was the light of all humankind. The light shines in the darkness, and the darkness has not overcome it. And the Logos became flesh and made its dwelling among us. These are words inspired by God. Please hold on to your hats. You're sitting on a globe that's rotating on its own axis. And if you live on the equator, you're moving at 1,000 miles an hour. As you go north from the equator, your speed is less and less. But at the equator, you're rotating at 1,000 miles an hour. And you're sitting on a planet that's going around the sun in a huge circuit every 365.23 days. And that journey, that speed of the Earth going around the sun is 67,000 miles an hour. And the sun's circuit is going around the center of the Milky Way galaxy at 504,000 miles per hour. And this Milky Way galaxy of ours is orbiting a supersized black hole in space at 1,350,000 miles per hour. Are you dizzy yet? For September, I chose as my theme, how did creation happen? And last Sunday, I spoke about the biblical theory of creation, particularly from the book of Genesis, chapter 1. And I said that I was going today to look at the scientific theory of creation and my own theory of creation. But during the week, I changed my mind because I came across so much stuff in reading and researching that I decided I need to devote three homilies to this topic rather than this two, because there are 5 Sundays in September. So last Sunday, I looked at the biblical account of creation. Today, I'm just going to look at the scientific theory of creation. And then next Sunday, God willing, I'm going to look at some of my own theories of creation. September 22nd is a break, it's the community mass. So then on September 29th, I'm going to do a recap of the 3 homilies and do a Q&A. So today I'm going to focus completely on the scientific explanations for our universe. Now, the basic kind of technique of the scientific model is that the sciences operate basically by observation of the natural world of the cosmos, and also by experimentation. So these are the 2 wings of science, observation and experimentation. Now, there's a whole way that the scientific model works. So any scientist in any area, whether it's geography or physics or mathematics, firstly begins to look at data. So she's going to gather a whole bunch of data in her field. So she's going to make observations and collect data of some kind. When she's collected her data, she's now going to look for possible patterns in the data. Is there some kind of a system built into the data I'm observing? So that'd be stage 2. Stage 3 is then, if she discovers a possible pattern, she's going to create a hypothesis to explain, what the origin of that particular pattern might be. Number 4, then, she's going to do experiments to either prove or negate her hypothesis. If it proves to be true, if she finds out, there's a 95% probability that this is true, then it has to be replicated in somebody else's laboratory to make sure that it wasn't just statistical kind of aberration. So some other scientists have to replicate the study. Now, if a bunch of them come to the same conclusion, now you've established a principle or a law within the field. And then the next stage is you put together a bunch of laws and you create a model of reality in the field. And that works for a few years. And then at some stage, you're going to have to tweak your model because new anomalous data constantly arise. So now you're trying to accommodate the new data into the old model. You're tweaking the old model to try to make sense and accommodate the new data. And finally, at some stage, there are so many anomalous data coming in that the old model is totally inadequate. So now you've got to break down that model completely and erect a brand new model that can contain all of the old data and all of the new data as well. So that's basically what the scientific model is. Now, in theory, this is a very elegant, a very humble, and a very open methodology, and it has conferred extraordinary benefits on us from everything from transportation to communications to medicine to agriculture. So this model has proved really, really, really effective. However, like everything invented by humans, it has its shadow side and some really glaring inadequacies. So I'm going to look at the benefits, the light and the shadow of the scientific versions of creation. The first problem is that all our instrumentation, all of our scientific instrumentation is basically an extension of the human sensorium. And therefore, it's subject to all of the sensorium's limitations and illusions as well. So I'm going to mention some of what the problems are and then get into the theories themselves. So, for instance, if you look at the electromagnetic spectrum itself, and if you were to represent that as a 3,000-mile long line joining LA to New York, the visible portion of that spectrum would be the diameter of a dime. So on that tiny little slice of reality, we're building some of our models. Now, you add into that the notion of dark matter and dark energy, about which science can say, yeah, absolutely not, it's totally ignorant. And dark matter and dark energy account for 95% of all the stuff in the universe. And so what do they mean? Dark matter is just the name that astronomers give to the mysterious something that's causing the universe to expand at an accelerated rate. Something is driving the universe into expansion. They don't know what it is, but it's some kind of energy, obviously, so they just call it dark energy. It's like if you give something a name, you think you've explained it, and obviously you don't. You're just giving a name to that which is still not understood. And the problem with dark matter, the second piece of it, is that dark matter does not interact with the electromagnetic force. This means that dark matter cannot absorb light, reflect light, or emit light. So it makes it very, very difficult to spot. In fact, researchers have only been able to infer the existence of dark matter from the gravitational effect it seems to have on visible matter. So we make up this word again because something is holding, for instance, a galaxy together, or kind of planetary systems around their sun, and they don't know what it is. So they call it, this some kind of gravity. They're going to call it dark matter. So we got dark energy, which is expanding the universe, and dark matter that's holding components of it together. Now you throw into that science's refusal to admit data from any other state of consciousness except the so-called waking state. So we deny any input from altered states of consciousness, or dream life, visionary experiences, transpersonal experiences, meditation. All of those data are neglected by science as being unimportant. You factor in as well the reality that the experimental method itself is based on probability theory. And so what you're saying is there's a 95% probability or more that the result we got is correct, but it's only probability. So it never actually proves anything. It's giving the probabilities that something might be true. So all science can do is infer a causal connection between events, but can never actually prove that A causes B. So all of these limitations add up to the kind of the shadow side of science. Now there's a light side to that as well. So when I troll through the history of science's efforts to explain the universe, I come up with the following kind of stages. So the first hit of science was that we lived on a flat Earth. That was the scientific theory for a long period of time, that we live on a flat Earth. At some stage, we went beyond that, and now we created a brand new model that was totally up to date and explained everything. And this was called the geocentric model, that the Earth is the center of the entire cosmos and everything revolves around about us. And that was the given truth for a long period of time. And then at some stage, with the Copernican revolution, we found out it wasn't true, that we live in a heliocentric system, helios being the Greek word for the sun. And so we realize that the Earth and the planets are going around the sun. So now we have a heliocentric model, and we think, yeah, that's it. And then at some stage, we developed what's called a galacticocentric model of the universe, that the entire universe is revolving around the Milky Way galaxy. And then we came up with a theory, and it was actually a Catholic priest who came up with the theory first time, a guy called Lemaitre, the notion of the Big Bang, that the entire universe started off with a huge bang. So these are the kind of the stages. That's one model of the scientific notion of the stages we went through. And at every time, at every stage of the process, scientists were convinced, now we found the truth, this is it. Only to find out it was radically inadequate. Now we have a better version, this is it. And then that was thrown out, and now this is it. So again and again and again, science is trying to reinvent itself. Now, another model then I came across was the notion of the 7 phases of cosmic evolution. So if you subscribe to the Big Bang theory in some ways, what happens is this. The first stage is particulate matter, the creation of particles for stage 1. And that happens for a tiny, tiny period of time. And then you have galactic, you have the formation of galaxies. And most of us think that, stars, come before galaxies. That's not true. Galaxies come before stars. Galaxies are just these huge kind of clouds of particles that are held together in some kind of form called a galaxy. And then at some stage, the third stage is stellar creation, that some of these particles come together within the galaxy and they form individual star clusters. So the galaxy comes before the stars come. And the fourth stage then is that some more of this kind of particulate matter that was kind of left over from the formation of the stars now leads to the formation of the planets, which are in attendance upon the star systems. And once that gets established, you've got planetary systems. Now there's a breakthrough they call the chemical stage. Now chemistry is at work. And the next stage then, biology, that life somehow emerges from chemistry. And then finally, the claim is that we are now at the cultural stage of the evolution. So we start off with particles, then galaxies, then stars, then planets, then chemistry, then biology, and finally culture. And that culture now is the great driver of evolution. Now, according to the latest model, then, the Big Bang created space, time, energy, and matter. They're the 4 basic components of science at our times. That the Big Bang created space, it created time, it created energy, and it created matter. And when you ask the kind of logical question, well, what was there before the Big Bang? And where did the Big Bang happen? And the physicists will tell you that's nonsensical. You can't ask what happened before the Big Bang because the Big Bang created time. And you can't ask where did the Big Bang happen, because they're going to tell you there was the Big Bang is what created space. So there was no before and there was no where if you subscribe to the Big Bang. Now, part of the conundrum is that at the speed of light, as you move faster and faster and faster, mass becomes infinite, space goes to 0, and time goes to 0. So you've got the famous conundrum of the twins. You've got twin boys. They're now in their mid-20s, and one guy decides to be an astronaut, and he goes off into space, traveling almost at the speed of the light, and his twin remains on planet Earth. And the space guy goes off for maybe 3 or 4 years traveling, and then comes back to planet Earth, and he finds that his twin is now 95 years old, because time is going 0 as you travel nearer and nearer to the speed of light, and the guy on Earth has normal time, and the guy in space has gone 0 time. So these are some of the kind of problems that we come up against with the scientific model. Now, when you look at science in general, in any field, whatever the field is, the 4 basic questions we should ask in the scientific model is who, what, when, and where. So, when you're looking at any phenomenon in the real world, these are the questions you ask. Responsible for this? Some intelligent agent, either a human agent or a natural agent, but to use the Greek word, some kind of a logos, some kind of a morphogenetic agent is responsible for what the phenomenon that you're examining. So who? Some intelligent agent, human or natural, is the who. And what? What happened? It means there must have been some kind of a discrete event. as a scientist, when you're looking at a result, you're looking at what happened to create this result. So you're looking for some kind of an event. And you're asking, when did it happen? You're looking at a specific time in which this what happened in order to create the outcome that we're looking at right now. And fourthly, as a scientist, you're going to ask, where did it happen? In what particular location did the event occur? So right throughout the scientific model, you're constantly wrestling with these four questions. And if you can't answer any one of the four, it's unintelligible. There has to be a who, some intelligent agent, human or natural. There has to be a what, some kind of a discrete event that caused what you're examining. There has to be a when, there has to be a time when it happened and before which it didn't happen. And there has to be a where, there has to be a location in which the event occurred. Now, this is the basis of all real science. But when you get to the case of the Big Bang, there is no who, there is no when, and there is no where. And the what is the simplistic notion of an explosion that started smaller than an atom and now encompasses the entire cosmos. So there are the difficulties you have with the mythology of the Big Bang and the scientific model. Which brings me to the notion of, I'm going to call it the problem of postulates. Those materialistic scientists who mock mythology and sanctify science understand neither, because both systems are just stories predicated on unproven and unprovable postulates. So all of science is based on faith. This is true in pure mathematics, it's true in physics, it's true in philosophy, it's true in geometry, and it's true in every branch of science, just as it is true in religion. It's based on faith and postulates. Now, one of the first one is the doctrine of what's being called uniformitarianism. This belief in science that all the laws of the universe are the same everywhere and throughout all of time. That since the very, very beginning, the laws of the universe have been set in motion, and wherever you go in the universe, and whatever time you're in, the laws are unchanging. This is called uniformitarianism. Now, there's actually empirical evidence suggesting that the force of gravity has actually changed over time, and that the speed of light has changed over time. But the uniformitarianism doctrine is that wherever you go and whatever stage you're in, the laws are always exactly the same. Except one glaring case. The most basic law of the scientific method is the law of karma, the law of cause and consequence. If you see a result A, there had to be a cause B that created it. So the most basic law of science is the law of karma, cause and consequence, cause and effect. Now, they're asking us, the scientific belief in the Big Bang calls for a causeless consequence. They're asking us to place our faith in a mega miracle, faith that, that makes the resurrection of Jesus and the doctrine of the Immaculate Conception look like minor miracles. But that's what they're asking us, to have to believe that there was a Big Bang before there was time, before there was space, and that everything has come out of this. There has been no cause for it. There are consequences without cause. This runs completely against the most basic law of science itself. And I'm going to give you a few examples from sub-branches of science. My college major was mathematical physics and pure mathematics. Now, pure mathematics is often called the queen of the sciences because it is abstract reasoning at its most elegant and its most unencumbered. And yet, pure mathematics is based on faith. In 1889, an Italian mathematician called Giuseppe Peano, spelled P-E-A-N-O, created the 5 axioms of natural numbers. And thereafter, they've been known as the Peano postulates. And they are meant to be a rigorous basis for number theory, like the natural numbers 0, 1, 2, 3, 4, etc., which we use in arithmetic and in number theory and in set theory. Now, the problem with the Peano postulates is that none of them can be proven. But if they're taken on faith, you can build very powerful and very useful theories. But they cannot be proven. None of them can be proven. Now, by the beginning of the 20th century, scientists in general and mathematicians in particular were becoming convinced that they were on the verge of creating a system that could be built from the ground up without any need for faith or postulates. And then, alas for hubris, along came a brilliant Austrian mathematician, a guy called Kurt Godel, who in 1931 proved that no axiomatic system of natural numbers can be both complete and consistent. It can be one or the other, but it cannot be both. If it's complete, it won't be consistent. If it's consistent, it won't be complete. Now, this, in some senses, this was the mathematical equivalent of the Heisenberg uncertainty principle in quantum mechanics, which was formulated by the brilliant German physicist Werner Heisenberg in 1927. And the uncertainty principle in quantum mechanics says that we cannot simultaneously know the position and the speed of a particle, such as a photon or an electron, with perfect accuracy. If the more we nail down its position, the less we know about its speed, and vice versa. So Kurt Godel did this for mathematics. And it's not just that mathematicians aren't clever enough to manage it. Godel proved that it can't be done, ever, by anybody. Faith in at least one unproven postulate is always necessary, even in pure mathematics. And you can actually extrapolate from Kurt Godel's work that any axiomatic system, not just numbers, but any set of propositions cannot simultaneously be consistent and complete. So any logical set of axioms, and they're the building blocks of philosophy, must have at least one postulate which cannot be proven. So without faith, philosophy is not possible, nor is pure mathematics. And we got the same problem with geometry. Some 2,200 years before Giuseppe Peano's time, Euclid ran into the same issue with his elements, his set of geometry propositions. And these are based on 5 unproven and unproven postulates. And the frustrating thing is that these postulates appear to be actually self-evident. Like, for instance, one of his postulates says the shortest distance between any 2 points is a straight line. Obvious? Yes. Provable? No. Not even by the finest mathematical minds over the last 23 centuries have been able to prove any one of these. Faith is necessary for all of them. Which brings me to my final point. I finished reading a brilliant book called Darwin's Doubt, written by a guy called Stephen Mayers, who was a PhD in the philosophy of science and was a geophysicist himself. And he's talking about the evidence within the DNA sequencing for some kind of intelligent design. And he's proving that, modern mathematical formulations have shown the utter improbability of 3 things I'm going to mention. So when you do the math on it, the utter improbability, firstly, that the cosmos arrived ex nihilo, that there was one great miracle that caused the cosmos to come into being. There was no place and there was no time. It was before place and it was before time. So the mathematical improbability of that is absolutely vast. The second notion is the utter improbability of life emerging from dead matter, the biosphere coming from the physiosphere. The kind of the life on planet flora and fauna coming from a rock, a lifeless rock. And the third piece, the realization, and this was Darwin's doubt, that evolution between species, there's no evidence for evolution between species, but there's a lot of evidence for adaptation within the species. So the adaptation happens within an existing species, but it doesn't cause one species to become another species. I spoke a few weeks ago, my theory of the difference between data and information. Data for me are just random pieces, whereas information is putting them together in some kind of an intelligent format. So if I give you random data, I give you 4 letters, E, I, L, and V. That's just random data, it's meaningless. But if I organize them in the following fashion, E, V, I, L, or L, I, V, E, I've given you information now. You're talking about evil or you're talking about live. And so when you organize data, in some ways, it becomes information. I gave you a second example from mathematics. If I give you the random data, I give you letters and numbers, I give you A, B, C, and X, I give you the numbers 2 and 4, I give you the symbols plus, minus, divided by, and the square root of, they're kind of just, they're data points. What are you going to do with them? But if I put them in a particular sequence and I say to you, X is equal to minus B, plus or minus the square root of b squared minus 4a over 4ac over 2a, I've given you the formula for a quadratic equation. And that's hugely meaningful and has extraordinary pragmatic consequences. Now that's the difference between raw data and information. Now when you examine the base pairs of DNA and you find A, T, C, and G wrapped up in the interior of this double helix. So what they're finding out is that these are not just raw data, but they're combined into information. That these four, base pairs, they create words, biological words. They create biological sentences. They create biological paragraphs. They create biological instructions. In fact, they create an entire manual for the creation of a species. Whatever the species is, and you examine the DNA, you're not dealing just with, four kind of discrete data points. You're dealing with words, sentences, paragraphs, instructions, and an entire manual about how to create that species. In fact, they're showing mathematically there is more information in a single cell than is contained in all of the information on the internet right now. Every single cell has more information locked into it in a single cell than the internet has. So here, what's my conclusion about science and our explanation for the origin of the universe? God loves a trier. Religion needs to keep trying. Philosophy needs to keep trying. And science needs to keep trying. Those at the other side of the veil keep encouraging us. So let's listen to them with our senses, with our intellects, with our intuition, and with our souls. Namaste, my brothers and sisters.